Okay, welcome back. We are looking at part number 2 of entity modeling. Now we have some keywords that we need to note here. We have a super key, which we're saying a super key of an entity set is a set of one or more attributes whose value uniquely would determine each entity. So it's more of an attribute that we can use to be in a position to uniquely identify an entity. And remember we said candidate key would be any key that we could use to uniquely identify, though we are not using. Like example, if we have registration number and on the same table we also have maybe national ID, we expect the content of those two to be unique for every entry in that particular table. But since it is a school setting, university setting, we may decide to go with registration number as the primary key, though we could have used the national ID as a primary key. Hence the national ID now is a candidate key. So that's the difference between the primary key and candidate key. Now, the combination of primary keys of participating entities set forms what now we refer to as the super key. Now we could have a customer ID and also we can have an account number. Those two, wherever they are in a relation, there they would be super key. You can use either to be able to uniquely identify a record, or you can use all of them. So example, if we wish to track all access dates to each account by each customer, we cannot assume the relationship for each access. So we can use a multi-valued attribute though. So we can be able to use a combination of those two to be able to get the exact records that we are looking for. Must consider also mapping cardinality, and we did explain what cardinality was in our part number 2. So here we have ERD diagram between customer and loan. Now we are drawing this representation or diagram where we have an entity customer, and at the same time we are showing the attributes that belong to that particular customer. Now one thing you'll notice is that as we're giving these attributes for the particular customer, one of them is underlined. That one is underlined, customer ID. Now, when you're drawing these diagrams, always make sure you underline where the attribute itself can uniquely be used to identify, and you have already selected it as a primary key. So if you give a database developer or a system developer to be able to develop a database, this kind of diagram, he'll be able to figure out that I need to create a table called customer, and these will be the attributes that we find in this particular table. However, one of them, that is the customer ID, will be the primary key. It has already been identified by this underline. So the rectangles basically represents the relationship set. How are these two related? And this is the rectangle that we are talking about. I mean, sorry, this is the diamond that shows the relationship between customer and loan is borrower. These rectangles here are the ones that are explaining, or that are showing us which one is the entity. The lines link attributes to each entity set, and these lines, remember, they can be used to be able to show us the degree of relationship, that is the cardinality. Now here's a more detailed diagram. Here we have customer. Now if you look at customer, we have a name. We can see we have name. That is the name for the customer, right? This customer has an ID, which we say that we're going to select that as the primary key. But this customer also has a phone number, which is multi-valued. Now, again, we have date of birth. But then there is an entity here we are seeing that has the dotted line here, this edge. Now, the fact that it has dotted line tells you that we don't even need to store, we don't need to store it in our relation, because this is what referred to as derived attribute. It can be derived from date of birth. So if you have this kind of drawing, there's understand that that is a derived attribute, and these will be a multi-valued. That is, when it comes to phone numbers, the way a phone number is structured, it can be structured in such a way that it can even give you the area code, maybe country code and all that. So it has different parts, hence it is multi-valued. Same applies to address. Now look at the address. Here we have address, and at the same time we have a representation of state, city. We also have the streets, but if you look at street again, it has other values that are used for purpose of describing a street. So a street is not just a street, but it comes with these other attributes that we are seeing here. If you want the street, get all these attributes. That's what we are saying. If you want complete information of the address, then get all the city, state, zip code, and so on. You're going to get the complete address. Same applies for the name. Name is not just a name. There is a first name, there is middle name, there is last name. So in database system, we just don't store name as one attribute. So in other words, what I'm saying is that you will have the table customer. But in this table, what represents name is first name, middle name, last name. So we won't have an attribute showing in that particular table that we're referring to as a name. Now, we can have a relationship set. We say the one in diamond is a relationship set. So we can have our relationship set here. Depositor. Now, the relationship set depositor, if you look at it as an attribute. Want to know when the deposit was made, so you can create it in such a way that it will always give us other additional information. Now we have customer and then account. Now remember, relationship sets, we can also use them to be able to dissolve a many-to-many relationship, like in situations where we have a customer who can have many accounts, or we can have accounts that can be owned by many customers. Then we find using relationship sets an easier way for us to be able to dissolve that kind of relationship. Now remember, there was a time we talked of a relationship where we can have maybe an employee who's a manager and then is also an employee. That is a recursive relationship. So we can be able to define a recursive relationship as such. So we don't need to come up with another rectangle somewhere here and say this is a manager. No. What we can do, the best approach is, let's get the rectangle that represents the entity employee. Then let's get the attributes of this particular employee. So if there is an issue of manager, then we can create this kind of recursive relationship. You can see it is going back to, from this entity, it goes back to the entity again. So that's a recursive relationship. It's based on a role that is being played by one of them. Cardinality constraints, remember we talked about that, where we can have maybe a professor who can teach more than one unit, but can only teach a maximum of, say, 3 units and so on. So again, now we can express this cardinality by drawing lines. A direct line would imply 1. That is, or an undirected line without an arrow, it would signify many. Now let's see. So it means now this basically is let me get the pen. These are many to one relationship. That is, a customer can have many loans. Many loans can be associated with one customer. And then we have the relationship set here is to borrow. Now again, this will be what? These are many. We get the pen. These many to one. Now, it's the same kind of representation that we have talked about. Many customers can have one loan, especially if you are in a group and you approach a bank and you request for a loan, you're given a loan. Then since you are many customers, then that can be a many to one kind of relationship. Many-to-many relationship, it's here again, but remember we said that it is dissolved using the relationship sets, and our relationship set borrower there has been able to dissolve this kind of relationship. These are many-to-many relationship. Now, we have what we refer to as total participation, indicated by double line. So the only way we can have these relationship sets that we are seeing here, the borrower relationship set that we are seeing here, it is can only participate in this kind of relationship if there is a loan. So there is a total participation. That is, participation of a loan in borrower is total. There can never be any other relationship. That is, we can only have a borrower relationship set if there is a loan that has been borrowed. So that is a total participation. So we have alternative notations that we can use for us to be able to represent the cardinality. Now you can see we can use this approach where we are saying 0 to star could mean many, and then here that is a customer may have a loan or cannot have a loan. I mean, may or may not have a loan. However, if there is a loan can be associated with one customer. So you can be able to set those kind of limits when you are defining that. Now look at this kind of relationship that we have in here. It's a ternary relationship, where we say it's a relationship between where we have more than two. Now we have included a job here, and it has come about as a result of this relationship set works on. So we have an employee and then we have branch, but this employee has a job in other branches. Remember that explanation we gave earlier. So that's basically what it's all about. So cardinality constraints on ternary can also be set. Example, an arrow from works on indicates each employee works on at most one job at any branch. We are referring to this. So if there is more than one arrow, there are two ways to define the meaning. Example, a ternary relationship R between A, B, and C with arrow to B and C could mean, number one, each A entity is associated with unique entity B and C, or each pair of entity, that is A and B, is associated with a unique C entity, and each pair of AC is also associated with a unique B. So each alternative has to be used when we want to be able to differentiate the kind of relationship that does exists. And to avoid confusion, we basically outlaw uses of one arrow and all that. Binary, we say this is basically the normal or the common relationship that we find in most databases. So we can also have a non-binary, whereby we're saying some relationship that appear to be non-binary may be better represented using binary. Now, a ternary relationship, parents relating to a child to her father and mother, is best replaced by two binary relationship, where we basically either refer to father and mother, or using two binary relationship that is allows partial information. Example, only mother being known from a child to a mother, that kind of relationship. But there are some relationships that are naturally non-binary, like works on. So that is non-binary. That means it's not a one-to-one anymore. That is, we are not looking at two entities anymore. We are looking at more than one entities, because we cannot have a relationship between one and nothing else. So it says a relationship between one and another, and that is two, or it's a relationship between more than two, and that is the ternary relationship that we have just talked about. So mapping cardinality affects ER diagram. Now look at the diagram that we have in here. Now we have from customer, and then we have an account. We know generally a customer can have more than one account in a bank, right? Yeah, more accounts. We can have different accounts being owned by one customer. So that customer would be depositing to different accounts. So that's the kind of relationship that is being depicted here. So how, if you have this kind of diagram, then you need to find a way to be able to represent that using your ERD diagram. We have situations where we now talk of weak entity sets. Any entity set that does not have a primary key is referred to as a weak entity. It is weak since there is no way we can be able to uniquely identify any input that you're going to make into that kind of relationship uniquely. I'm talking of uniquely. So the existence of a weak entity set depends on the existence of an identifying entity set. It must relate to the entity identifying the entity set via a total or one-to-many kind of relationship. So we have a discriminator. Now, if you're using a discriminator now, that will be the partial key of that particular weak entity set. It is a set of attributes that distinguishes among all entities of one weak entity set. So if you use a discriminator, then that's how we can be able to work with it. We have the primary key of a weak entity set is formed by the primary key of a strong entity set. So it implies basically there is a relation without that particular way of uniquely identifying. Hence, there is a need for us to use the discriminator. So you need to note that the primary key of a strong entity set is not explicitly stored with the weak entity set, and that is why that relation will not be having a primary key, since it is implicit in identifying the relationship. So we just basically just imply. So if we have long number where explicitly stored, payment may be made a strong entity. So a long number is existing because there is a payment that has to be made. So that's basically what we are now referring to as that weak entity. Now, when you're making the ER design decisions, we have the use of attributes or entity sets to represent an object. Whether a real-world concept is best expressed by an entity set or a relationship, you need to be able to figure that one out when you're coming up with your ERD diagrams based on the business requirements that are in existence. So the use of ternary relationship versus pair of binary relationship, do you wish to have that kind of representation in your diagram? Consider that too, especially like you've seen where we are saying wax on, which is non-binary relationship, and now ternary relationship. So the use of a strong or weak entity, consider that also, because at the end of the day, remember, we're trying to come up with a database that is efficient in terms of resources. Are you reducing on duplication and redundancies? Consider if that will have any effects. So the use of specialization or generalization contributes also to modularity in that particular design, and that will be very important for you to be able to consider, especially if you need an efficient database system. So the use of aggregation can treat the aggregate entity set as a single unit without the concern of the details of internal structure. Hence, now the developer will have to figure out the internal structures. So we have ERD diagrams for, this is just an example of ERD diagrams for banking system. Now you can see how different entities, remember entities, say they are represented by rectangles. We have rectangles here for customer. We have another one for payment there. And you can have another one here. You can even see the recursive relationship works on. You can also see the total participation there, right? And we have so many entities here. We have that entity, we have that particular entity. All rectangles represent entities. The ellipse represent the attributes of those particular entities. And remember, we said the diamond shapes are the relationship set, and then we said also that any underlined ellipse would be the primary key. So this basically just shows maybe an example of a complete banking enterprise ERD system. And then we have a representation of what each symbol is all about. Now you can see like the multivalued attribute that we talked about here, that represents multivalued, that is derived. We have a total participation. We have this kind of representation where you're talking of many to one. But remember we said you can use whichever approach that you feel fits well. Like some would prefer maybe the use of the profit and all that. So what else do we have here? Yeah, we have that's basically many to many, as we had seen, and then we also do have many to one there. Then you can set limits, like when you're saying the professor can only teach one to a maximum of 3 units. Those are cardinality limits that you're setting. And then remember, arrow represents 1, hence that is a one-to-one relationship. So reductions to relation schemas. Primary keys allow entity sets and relationship set to be expressed uniformly as relation schema. So at the end of drawing this particular ERD diagram, now you can be able to come up with the real tables with attributes set, and then you can be able to show the relationship from one particular table to another table. So if you're going to represent an entity in a schema, basically like example payment, then you must be able to show its attributes in terms of maybe columns. What else? Building from ER to relational model, that is from ER to the table, as I'm saying. Whether you're going to create your tables using whichever kind of database management system that you're going to create, whichever, that is out of the topic here. You're going to consider that later, but you need to be able to draw those tables so that you can have a clear picture of what you are talking about. That's why I'm saying building a table from each particular entity. Build a table for each relationship set if necessary. Make columns in those particular columns. You basically know that a table consists of rows and columns. So the columns will be for attributes. The rows will be for the records that you're going to enter there. Then we have indivisibility rule and ordering rules. So we have what? Primary keys must also be set. Here's an example of what we're talking about. We have a simple ERD diagram between student and professor, and we have the relationship set is about advisor. Then this implies now we can be in a position to convert these ERD. The one for student, you can convert it to a table as shown there. There it is. The one for professor, you convert it to that. You can see it is having the 3 attributes. Those are the 3 attributes that we have in the ERD. Here we have the 4 attributes that we have in the student table. So that's how you're basically able to do the conversion from ERD to that. Now, a many-to-many relationship set is represented as a schema with attributes for the primary key of the 2 participating entities and any descriptive attributes of relationship set. Remember, the relationship set is the one that dissolves the many-to-many relationship, because we are trying as much as we can not to have what? A many-to-many representation. So our entity set, which could be borrow, now can have what? That is borrower, now can have its own attributes, and you can present that as its own table. Now here we have an example of, we have total participation here, and here we have account and branch. We have account and branch. Now you can see the arrow represents 1, right? Now every entity is given its own attributes. Now that's a redundancy of schemas, that is many to one, one to many. Example, instead of creating a schema for relationship set, account branch, add an attribute branch name to the schema arising from that. So you can also be able to add the branch name itself. Like, let's see, where do we have that? No, we went past that, but don't worry. Anyway, so we have redundancy schemas, that is for one-to-one relationship set. Either side can be chosen to act as many. If you have that kind of relationship where you see in future that you're going to have more than one kind of relationship, hence increasing the degree of cardinality. So we have composite and multi-valued attributes. We looked at that, and we were able to see names can form part of that. We also saw that the address can also form part of that. Hence, they will also need to be able to represent that in your database as you are creating the database. And I think the rest we had already seen. We saw method representation specialization. We saw method 1, form a schema. Form a schema for higher level entities. Then the other one was form a schema for each lower level entities. That is, you need to look at it from the perspective of the general entity and then its attributes. Here's another ERD diagram example where we are seeing, I think this is for books, where you're buying books maybe from a bookstore, and we have books attribute here. Sorry, let me try to get the pen. So we have the book attribute there. Shopping basket can also form an attribute, and then we have customer forming an attribute, sorry, an entity, and then we have publisher entity, and then we have author also as an entity, warehouse as an entity, and then remember the diamonds are forming the relationship set. Now you can see we have a relationship set contains also having an attribute there. So we can have those kind of representation, and each entity has its own attribute, and remember attributes must always be underlined if they are going to be the ones that are uniquely identifying that particular entity. Another example, still having the same kind of representation. Here we have three diagrams, A, B, and C, all communicating basically what we've been able to talk about from our discussions. Another example is there, entity, employee, having its own attributes well clearly defined in A, and also in B, having employee and then telephone entity, and there is a relationship set there that has been clearly set. That is a relationship set, employee telephone number. Here we have another one, figure 6.16, where we have loan as a relationship set. And if you look at loan as a relationship set, now it has its own attributes, because we are having a participation, a relationship between customer and branch, and that relationship is through the loan itself. Alternative ways that you can be able to draw your ERD diagrams, you can use these kinds of representation, either we can use the Profit. Profit is the one that we have in here. This is profit kind of representation. When you are talking of many to many, this would be the many to many. This part is the many to many. And it can also be represented as that. One to one can also be represented as that, or you can use that from the profit. Many to one can be represented as that, or you can use the profit again.